Okay, never mind. After looking at the requirements, I realized I never actually did a walkthrough of my code, and I guess I don't know. It almost seems pointless because the stuff my code is actually doing is very basic, very reinventing the wheel here. But I guess I better do it. So I println start so I can make sure the code is actually running, just as a sanity check, and then it logs the current system time, and then I define size. I call it size because it's the size of the array, or well, vector. But it's just this is the number that is the ceiling on like what's the highest prime number we can possibly find. I mean, obviously that's an even number, so that's not prime, but whatever, that doesn't matter. And then we declare this really big vector. If you try and make it an array, it will allocate it to the stack and overflow. So you got to make it a vector so that it'll allocate to the heap. It actually, now that I say that out loud, it does seem kind of strange that a language like Rust of all languages wouldn't have a way for you to say, hey, allocate this array to the heap instead of the stack, but still otherwise let me retain the nice properties of an array. But maybe the way with memory, I don't know enough about how memory works. That might not be possible outside of the stack now that I think about it. Well, except that, no, I don't have time to explain that. And then that should be closer to that to indicate that this is. In fact, I'm going to put this under the comment just so it doesn't look isolated. I don't know why the indentation is all weird all of a sudden. And so this just so it gets initialized to true, and then I knock out all the even numbers as its own thing, just so that when I'm incrementing the coefficient here, I can do it 2 at a time and double the speed. And you can use wheels to get more speed up, but the returns diminish incredibly quickly. And then I just manually say 0 is not a prime number, 1 is not a prime number. I'm literally just using the index to be like the number. So I'm not saying that 0 is actually 1 or anything. 0 is 0, 1 is 1. And then you have 2 loops in a Sieve of Eratosthenes. You start with the smallest prime that you haven't done this loop for yet. So since we did 2 manually, we start with 3, and then we declare a coefficient, and it's going to start off being equal to the prime. So all the even numbers have been marked composite, and then we are going to say these are both 3, and then you just say times 3 times 3, that's not prime, that's composite. 9 is composite. And then you increment the coefficient by 2. So you check 3 times 3, and then 3 times 5, or I guess I'm listing coefficient first. So 5 times 3, and 7 times 3, and 9 times 3, and 11 times 3, and 13 times 3, all the way until coefficient times prime is as large as size. It has to be less than, not less than or equal to, because if we're equal to, that would overflow the array. The vector. Then you increment. This should really be a do-while loop. I don't know if Rust has that, so you get to have the redundant line of code instead. Increment the prime number by 2 until it's actually prime. So like, let's say we get done checking 23. And then it'll increment to 25, and then this loop will run because 25 isn't prime, and so then it'll say increment 2, it'll be 27, still not prime, it'll increment 2, it'll be 29, and then it will be prime, and then the loop will exit. And then we record the time, that's how long the culling takes, and print that. That was the first number you saw there, 2.62 seconds to get up to 100 million, pretty fast. And then you literally just count through the vector as fast as you can and say anytime if data of I, like if I is prime, primes plus equals 1, and then print that, and counting that takes another 0.32 seconds. And then I have my benchmarking details here. Oh yeah, traversing the array took exactly 320 milliseconds in both C# and Rust. and then my rough translation took longer than the C sharp. The two I found online, this more idiomatic one I found, uh, I remember it getting faster times at first, but then slower when I scaled it up to a billion. And then the crazy fast Civ did it in like 5 seconds. C sharp took 18, the Rust translation took 30, and then the idiomatic one, I forget how long the idiomatic one took to do a billion. But yeah, so that was really fun to get to see that hands on. I have other functions here, but like the Fibonacci sequence, this really isn't that interesting. Golan's conjecture is not that interesting either. You literally just times 3, add 1, divide by 2. That's just not that interesting. But I'll show the code for completeness sake, I guess. Oh yes, and then the guess the number. This is all just copied from a tutorial with my notes here. Yeah, kind of embarrassing. Some of the notes that are still in here, I should have cleaned this out first, but it's already 1 a.m. I need to go to bed. So, yeah.